Alright, we're going to look at functions, domain, and range. As you probably already know, 2 lines, cut it to the margin and then all the way down, just like I'm doing in the video. And you think to yourself, I'm a good person. Now, so go ahead and pause the video and then copy this down, what a function is, what domain and range is. And I'm just going to show you in a graph what domain and range is. So say this is a function. The domain is going to be the set of x, and the range is the set of y. So the range is from the lowest point to the highest point. That's going to be the range. It's your y. Your domain is from the smallest x to the highest x. That's going to be the range for which the graph exists. Okay, so it cannot be somewhere where the graph does not exist. So the graph actually has to exist at that point. Alright, so we're going to take a look at a couple of examples. But just to let you know, for every one input of x is exactly one output value of y. That's really the key thing that you need to remember. For every one input of x is exactly one output value of y. So if I picked a point anywhere on this graph, I'm going to get one output of y. Now it's okay for me to pick another different point and get that same output of y. But what I cannot do is pick one x and find two y's. That's really what I'm trying to say. Alright, so let's take a look at different ways that you can get this question asked, because actually there are plenty of ways. So let's take a look at an example. Let's say that you have these relations. This is a listening check, shading the number 2 in the first parentheses. So your domain will be all your x values, and I'm just going to put them in order. So smallest one's going to be -1, then 0, then 2, 3, and 5. Your range is going to be all your y values, and again I'm just going to put them in order just because I'm used to doing it. So that's a -1, 0, 3, and then you see if 5 happens twice, you're still just going to write it only one time. Then my third question is going to be, is this relation a function? Is this a function? So remember, for this to be a function, for every one input, there has to be exactly one output of y. So I'm going to look to make sure that x does not repeat. So basically, x cannot be the same. This is a listening check. Put a box around the x. Put a box around the x. So I'm looking at all the x values. They do not repeat. They're not the same. So because they do not repeat, yes, it is a function, because for every one x, there is one y. So let's look at a different example. Let's say they give it to you looking like this. So the domain would be all your x functions. So we're looking at 2, 4, 5, and 9, all your x values. The range will be -2, 0, 2, and 4, all your y values. And then see if this function exists. Remember, for every x input, they can only be exactly one output. So if this is a function, for every x is only one y. But if you look right here, for that one x, it gives you two y values. But remember, we can only have one. So that 5 is going to give you 0 and 2, and that 9 is going to give you 2 and 4. So note, this is not a function, because for every one x, I must get one y. So let's say you had a linear function looking like this, a straight line. What is the domain? So remember, the domain is all the x values. So do you see that the graph exists for all values of x? So the domain is all real numbers, and that's how we represent all real numbers. Like capital R with another little slash inside. Now, if that's the domain, what is the range? Remember, the range is when you plug in all the x's, what values of y do you get? Do you see from negative all the way to positive? It is defined, so it's all real numbers as well. And then the question is this a function? It's really, really simple to see if this is a function. You just do the straight line test, and what that means is you just draw a vertical line going down, and if it crosses the graph more than one time at any given point, then it is not a function. In this particular function, it only crosses exactly one time, so yes, it is a function. That means only one x value gives you a y. Alright, let's take a look at an example. I'll give you an example. Same thing of a graph, only this time I'm going to make it cross more than one time. So let's say it looks something like this. So again, if this, I asked you for the domain of this, where does all the x values exist to? In other words, where is there a value for all x? Well, there's an x value starting from -3 to infinity. So you can write that out as x, the domain is x is greater than or equal to, because it is defined as -3, then -3. Then the range is when you plug in these x values, what are you going to get? Well, if you look at the output for the y, the range is going to go from negative infinity to positive infinity. The graph goes on forever. So the range is actually all real numbers. Then if this is a function, so again, the vertical line test says that all you got to do is draw a straight line vertically. If it crosses at more than one point, okay, then it is not a function, because it's only one y value, but that same x gives me two values. So that's why the vertical line test works. So it is not a function. So let's take a look at another example. Find the domain and the range of f of x. This is a listening check. Color the O in the word domain. Color the O in the word domain. Now, because we've done pairing transformations, I'm actually going to use that to do this. Okay, so what I'm going to do is I'm going to draw different transform graphs. So I'm going to start with x squared. I'm just going to sketch x squared. So what does that look like? A u that goes through the point 0, 0, 1, 1, negative 1, 1. And you can just do that by plugging it in. Then that negative outside is going to flip it over the x-axis. So that's negative x squared. Then I'm going to move it to the right 3 and up 1. So I'm going to make a couple of points so I can know where I'm moving this point. So 1, 1, negative 1, 1. When you flip them, it's going to be at negative 1, 1, and negative 1. And then I'm going to move it right 3 and up 1. So I'm taking all those 3 points. So you just need 3 points for parabola. And I'm going to graph where it goes. So that first point is going to go to 2, 0. So yeah, 1, 2, 3, and up 1. 1, 2, 3, and up 1. I bet you still ain't even leave your house. 1, 2, 3, and up 1. Alright, so this is what the graph looks like. Then it's really, really simple to spot out my domain and range. Remember, my domain is my x values. So looking at the x values, is the graph defined everywhere? Yeah, because as you go on forever, it's going to go on forever on the left, and it's going to go forever on the right. So yes, my domain is actually all real numbers. If I look at my range, again, my range is everything except anything higher than that first point there, which was a positive 1. So my range is anything is y is less than or equal to 1, because it is defined at the point 1. So it's really easy to look from a graph to see what the domain and the range is. Right, let's take another example. This is a listening check. Go ahead and put a circle around example 6. Put a circle around example 6. Alright, so I'm going to try and factor this out, because again, if I can make it look at the example above, I can quickly sketch it. So I'm going to factor out negative 2. That's going to leave me x squared minus 6x plus 10. And if I try to factor that, so I need two numbers that multiply to 10 and add to negative 6. And those numbers don't exist. So I'm going to try a different way. Again, in math, there are 1,000 different ways of doing the same problem. I'm going to find the vertex. The vertex is like the lowest point of the U. To find the vertex, there's a shortcut that says minus b over 2a. Coefficient of the x squared term, b is the coefficient of the x, and c is just the number. So go ahead and plug it in, and you're going to see that it's going to be 3. So the vertex is at the point x equals 3. So what I'm going to do is get points around x equals 3, making x my middle one. So I'm going to pick, let's see, so since I'm picking 3, I'm just going to pick 1, 2, and 4, and 5. And then plug it in. So plug it in, and what y values do you get? So when I plug in 1, negative 10. When I plug in 2, I'm going to get negative 4. When I plug in 3, I'm going to get negative 2. And you can just calculate these. When I plug in 4, I'm going to get negative 4. When I plug in 5, I'm going to get negative 10. So I'm just going to go ahead and plot this. I'm just going to quickly sketch, a graph. I just need to know what it looks like so I can see what the domain and range is. So make the different points and then plot the point 1, negative 10. This is a listening check. Shade in 10 in the table. Then I need the point 2, negative 4, 1, negative 10, 2, negative 4, 3, negative 2, 4, negative 4, and 5, negative 10. So it looks something like this. And it's just a sketch. I just need to know what the domain and range is. Now that I have my sketch, really easy just to look at it. So domain, again, it extends from both directions in terms of x part when it goes on forever, so it's all real numbers. And the range is anything less than that vertex point. So at that point, it's what? Negative 2. So y is less than or equal to negative 2 because it is defined at negative 2. Alright, let's take a look at another example. Alright, so I'm going to do a couple of quick ones, but you don't even need a lot of work. So the function is square root, and then what are we going to do with it? We're going to move it to the right 5. So this is what the square root looks like, and we're moving it to the right 5 points. And you should already know this real well by now. Now once I have this, what's the domain? Well, the domain can't go past that 5. So it's everything greater than or equal to, because it is defined at 5 as x is greater than 5. My range is everything positive, because you can see there's no graph on negative. So you could just write y equals greater than and equal to 0. Alright, let's take a look at one actually last example. We'll fit it over here. And if you can't fit it over here, just start a new page right behind this and keep that tab open. I just want to do one more. Let's say we had the function 1 over x plus 1. So what was the daddy for this one? It's 1 over x. And what does 1 over x looks like? Just like this. Then what are we going to do with it? This is inside, so we're going to think you're moving right 1, but you're moving left 1. So the vertical isotope is also going to move to the left 1, where it used to be the y-axis. It's going to be at negative 1. And then the graph just moves with it. Perfect. Alright, so now we're looking for the domain. So the domain looks like it's everything coming from the left, but not equal to negative 1, and everything going from the right. So domain is everything but x equals to 1. Then the range looks like you have all negative values and all positive values. So that's all real numbers. And that's pretty much it. It gets a little bit more complicated, but if you know the basics, you can do it. So let's practice.